Our task is to write the equation in slope-intercept form of the line that's given through the points 2, 4, and 5, 8. I have graphed these points on this coordinate plane. Okay, let's look at the line that extends through those points. Oh, I didn't do so good on that. Let's try that again. That's much better. Okay, so that's the line that goes through those 2 points. Okay, now we know that lines have slope, and that slope is a constant rate of change, that this line changes at the same rate all the time. And one way to determine that slope is to use a slope triangle. And that's where we look at how the line is changing from point to point. So this line is going up by 4 blocks when we go over by 3 blocks. Okay, and it's going to do that every time. I could find another point by going up 4 blocks. 1, 2, 3, 4, and over 1, 2, 3 blocks. There would be a point. Another point on this line would be about right there. Okay, I could find another point. So if it's going up 4 and right 3, then it's also going down 4 and left 3. So there would be another point on the line right here. There's actually a bazillion points on this line, an infinite number of points. But I like to call these pretty points because they have coordinates that are whole numbers. Now, our task is to find slope-intercept form of this line. Now, as you recall, slope-intercept form is y equals mx plus b, where m is my slope, which is my rate of change, okay, and b is my y-intercept, which is where the line touches the y-axis. Now, I hope you recall that this is the y-axis, this one right here. So where is the line touching the y-axis? Well, it appears to be touching right in that area. It's not a pretty point. It's not going to have a whole number, but we do know that the y value is between 1 and 2. We just need to see if we can figure out where it is between 1 and 2. Now, the other thing I hope you notice about the y-intercept, it's where the line touches the y-axis, so the x value is 0. So let's think about what we know about this line and how it's changing, and let's see if we can figure out a better, get a better idea of what the exact value of our y-intercept is. So we know that the line is changing at a rate of up 4 blocks for every 3 blocks that we go over. 4 blocks up for every 3 blocks over. Now, this would be helpful to us if it was more of a unit rate. So, my question is, how many blocks up for 1 block over? Well, if we think about proportional reasoning, what do I do to 3 to get to 1? I would divide it by 3. So I need to take the 4 and divide it by 3. 4/3. What's another way to write 4/3? Oh, 1 and 1/3. In other words, for every time I go over a block, I'm going up a block and a third. every time I go over, whoops, a block, I'm going up a block and a third, up a block and a third, because 4/3 plus 4/3 plus 4/3 gives me 12/3, which is the 4. Not sure that made sense, so let's not worry about that. But the unit rate is 1 1/3 block up for every 1 block we go over. Now, why might this be helpful to us? Well, we know the coordinates of the point here. We know that this point is 2, 4. What we need to know is, what is my y value when x is 0? Okay? So, if I could figure out the rate of change, the unit rate, then I should be able to determine the value of y when x is 0, and that's my y-intercept. Now, so we know that at 5, my y is 8. We know that. We are suspecting, or we believe, that our unit rate, so for every time we go over, and remember over is the x and up is the y, okay? So every time I increase my x value, my y value should increase by 1 1/3. So let's see. So at 3, I should be at 4 plus 1 1/3, which is 5 1/3. At 4, I should be at 5 1/3 plus 1 1/3, which is 6 2/3. And at 5, I should be at 6 2/3 plus 1 1/3. Is this 8? Is this unit rate working? Well, 6 plus 1 is 7. 2/3 plus 1/3 is 3/3. Is 7 3/3 8? Yes, it is. We have identified our unit rate correctly. So there's two ways to look at how this line is changing. Every time we increase the x value by 3, we increase the y value by 4. Or every time we increase the x value by 1, we increase the y value by 1 1/3. Now, we need to go backwards. So instead of increasing my x value, I want to decrease my x value. So if I decrease my x value by 1, I need to decrease my y value by, what's my unit rate? 1 1/3. So what's 4 take away 1 1/3? Well, that is 3 3/3 take away 1 1/3. That is 2 2/3. That's what the value is right there. Does that make sense? Does that look right? I think it does. We're over 1 and we're not quite up 3 blocks. So that means at 0, I would take 2 2/3 and I would subtract 1 1/3 because I'm going back another x, so I have to go back another 1 1/3. So what's 2 2/3 take away 1 1/3? Well, 2 take away 1 is 1. 2 take away 1 is 1. 1 1/3. Now, does 1 1/3 look to be corresponding with our estimate? Is it between 1 and 2? Yes, it is. So, and our unit rate is working. So if I increase by 1 1/3, starting, if I start at 1 1/3 and increase at a rate of 1 1/3, it's going to make the same line that's created by the points 2, 4, and 5, 8. So now we can write the equation of our line, and the equation of that line is, remember, y equals mx plus b. Our m, we have two ways of writing it. We can write it as 4/3 x, and our b was 1 1/3. We also could write our slope as 1 1/3 x plus our y-intercept of 1 1/3. Now, I know this looks odd because your m value is the same as your b value, and that is just a coincidence in this case. That does not happen all the time.